Welcome back, my calculus friends. We're taking a look at another second in our series of reviews for the AP test. This one is the key concept worksheet from section 1.4. So let's get started with that right now. The mention of curve y equals x squared should summon up the immediate mental image of a parabola on the coordinate plane. In fact, as soon as I said y equals x squared, you probably thought of a parabola. The following parametric curve descriptions are related to y equals x squared, so they're all related to a parabola, but they don't evoke the mental image as quickly. Graph the following curves, indicating direction for increasing values of t in the domain of the curve. Also, indicate the values of t corresponding to the domain endpoints and the point corresponding to t equals 0, if any. So this first one is just going to get us started. So when t equals 0, that's probably a good place for us to start on all of these. When t equals 0, the x-coordinate is 0 and the y-coordinate is equal to 0. Okay. So as t increases, the x-coordinate is also increases because x is the same thing as t. And then as t decreases, then the x-coordinate is also going to decrease. Now y is equal to t squared. So if t equal, we'll just do a few of these. When t equals 1, x-coordinate is 1 and the y-coordinate is 1 squared. When t equals 2, the x-coordinate is 2 and the y-coordinate is 2 squared. 1, 2, 3, 4 is way up over here. Likewise, when t is negative 1, y is equal to 1. When t is equal to negative 2, the x-coordinate is also negative 2, and the y-coordinate is positive 4. So we're looking at a graph of the parabola that proceeds just like that. So the direction it's going to go in this direction. Remember, when t is negative infinity, x is also negative infinity. And as t increases, x also increases. So there is our first one. These are a challenge, aren't they? The second one, when x equals negative t, y is equal to t squared. So let's, again, graph what happens when t is equal to 0. When t equals 0, I get 0, 0. That's not hard to see. What happens when t equals 1? Well, when t equals 1, the x-coordinate is negative 1 and the y-coordinate is 1. When t equals 2, the x-coordinate is negative 2 and the y-coordinate is 4. So here is that part of the parabola, and we are going in this direction. So let's work backwards then. When t equals negative 1, the y-coordinate, when t equals negative 1, the x-coordinate is 1, and the y-coordinate is 1 squared. So we're looking on this side of things to be going in this direction. Okay, let's do the next one. Now, when t equals 0, the x-coordinate is 0 and the y-coordinate is 0. When x equals 1, the x-coordinate, when t equals 1, the x-coordinate is 1 and the y-coordinate is also 1. When x equals 2, let me rephrase that. When t equals 2, the x-coordinate is 4 and the y-coordinate is 2. So for this part of the parabola, and hopefully you're seeing this as a sideways parabola, we are going in this direction. Let's go backwards. What happens when t equals negative 1? When t equals negative 1, the x-coordinate is 1 and the y-coordinate is negative 1. So this is going in this direction. When t equals -2, the x-coordinate is 4 and the y-coordinate is -2. So for this part of the graph, you can see we're going like this. So you can imagine graphing this in path mode. You'll see the circle move around in the clockwise direction around the curve. All right, moving on to question 4. X equals t squared and y is also equal to t squared. How's this going to go? What happens when t equals 0? That's always a good place to start. 0, 0. What happens when t equals 1? When t equals 1, x-coordinate is 1 and the y-coordinate is 1. What happens when t equals 2? Well, when t equals 2, the x-coordinate is 4 and the y-coordinate is, I don't know, 2 to the 4th power is 16, so that is way up there. So we're talking about something that does one of these, very sharp. And what direction do we move? Well, we're moving in this direction. Okay. Let's go backwards. What happens when t equals -1? Well, when t equals -1, we get 1, 1 again. So moving like that. What happens when t equals 2? T equals 2, we get the coordinate 4, 4,16. So off the map already. So this actually isn't going to give us a full parabola. It's only give us half the parabola. So for t less than 0, we go towards the origin, and for t greater than 0, we go away from the origin. So if you can imagine in path mode, the dot would go from here, then it would go this direction, and then all the way to the origin, and then it's going to go backwards out. So in and then out. All right, this one is going to get even nuttier, right? What happens with sine t and 1 minus cosine squared t? By the way, maybe we should simplify this into sine squared t. Because isn't that 1 minus cosine squared t? I think that we might find that a little bit easier. So what happens when t equals 0, x is equal to sine of 0, which is 0, and y is equal to sine of 0 squared, which is also 0. When when t equals, let's say, pi over 2, when t equals pi over 2, x is equal to 1, and sine is equal to 1 squared. When t equals pi, when t equals pi, we get the x-coordinate equal to sine of pi, which is 0, and the y-coordinate is equal to sine of pi squared, which is also 0. So what I'm seeing is this function goes back and forth like that. Now, what happens for the negative part? Well, if you can imagine, let's substitute negative pi over 2. The sine of negative pi over 2 is negative 1. And then the negative 1 squared is 1. So this part of the graph, it's going to go out this way and then back again. So I'm seeing this oscillating between just this part of the parabola. That's a tricky one. Let's look at number 6. This time they're telling us that t is only between 0 and pi, and it's never equal to pi over 2. So those are some really interesting restrictions that we're going to have here. probably related to the secant function, which is related to the cosine function. So what happens when t equals 0? The secant of 0 is 1 over the cosine of 0, and the cosine of 0 is 1. So 1 over 1 is 1. So the x-coordinate is 1. And the y-coordinate is going to be 1 squared, which is also 1. So that's our t equals 0. Maybe I should do that in red so that we'll have a good idea about our starting place. You're noticing that these are getting more difficult. What happens at pi over, well, we can't get to pi over 2. What about pi over 4? At pi over 4, the cosine is radical 2 over 2, which is about 0.7. And the size, so, sorry, at pi over 4, the cosine is radical 2 over 2, which means that the secant is 2 over radical 2, which is, I believe, just 1 over rad 2. How about 1 over rad 2 is, I don't know, 0.2 or so. What about the secant squared? Well, that would be, okay, so I'm getting mixed up with my mathematics here again. Cosine of pi over 4, that's equal to radical 2 over 2. So the secant of pi over 4, that's equal to 2 over radical 2, which is just square root of 2. So at pi over, when t is pi over 4, the x-coordinate is 1.4 about. So we'll just put a little notch right there at 1.4. Now the y-coordinate is going to be the square of square root of 2, which is 2. So that goes over here. So what we're saying is this graph will go over like this. Okay. Let's go in the opposite direction. Oh, no, there is no opposite direction. What happens at 3 pi over 4 when t equals 3? Actually, we should analyze what happens as t approaches pi over 2. So as t approaches pi over 2, secant approaches positive infinity. So positive infinity going this way. And then positive infinity squared, of course, that's just positive infinity squared. So I think I'm getting my inflection here a little bit wrong. It should be going more like this, in that direction. Now, thinking about this again, the y-coordinate should be greater than the x-coordinate. So I think I had my inflection correct the first time. So what was my inflection? Yeah, inflected upwards, kind of like that. Okay, so what happens then at 3 pi over 4? Well, at 3 pi over 4, the cosine of 3 pi over 4 is negative square root of 2 over 2. So the secant of 3 pi over 4, that's going to be equal to negative rad 2, or negative 1.4. Negative 1.4 is here. And then negative rad 2 squared for our secant is going to be positive 2. And then as we get closer to pi, the x-coordinate is going to grow to negative infinity, no, positive infinity. And our y-coordinate is going to go to, as we approach pi, the secant of pi is negative 1, and the secant squared of negative 1, of course, is 1. So we're approaching this point again, 1, 1. So we're heading in this direction toward that. Extend that the other direction, and we get this kind of a shape, where it's basically looks like a parabola that's been chopped off really at the lower half. So that's all of the parabola that's above the line y equals 1. And this is the direction that we go when t is greater than 0. No, from when t is between 0 and pi over 2. And this is the direction that we had when we're between pi over 2 and pi. That's a tough one, right? Let's move on. Number 7. This one looks a little bit easier. What happens when t equals 0? That's always a good place to start, isn't it? At 0, we get 0, 0. When t equals 1, the x-coordinate is 1, and the y-coordinate is also 1. So now we just got to figure out inflection. Is this inflected downward or upward? What happens when t equals 2? Well, when t equals 2, the x-coordinate is 4, and the y-coordinate is positive 2. So when t is greater than 0, we're moving in this direction. I'm sorry, those look too horrible, even by my standards. We're moving in this direction. All right. What about when t is less than 0? Let's go to -1. When t is -1, what happens? When t is -1, the x-coordinate is -1 squared, or 1, and the y-coordinate is also 1. So we're here again. So we're moving from here to here, which means we're in this direction. Just to verify, what happens when t is -2. When t is -2, the x-coordinate is also 4, and the y-coordinate is positive 2. So it seems as though we are moving in this direction. So if you can imagine the path of this particle, it starts off negative infinity, and then it goes toward the x-axis. This is all when t is less than 0. T is equal to 0, we're at the origin, and then it bounces back in the opposite direction that it came when t is greater than 0. Okay, a little easier than the previous one, I think. So let's take a look at this number 8. This one looks like it's going to be challenging. You've got e to the t and e to the 2t. I can see the square there, right? You can see the square. So what happens when t equals 0? Well, when t equals 0, e to the 0 is 1, and e to the 2 times 0 is also 1. So we get this curve right here. Right. As t increases, the x-coordinate is also going to increase, and the y-coordinate is going to practically double. So for example, when t equals 2, x equals e squared. E squared is somewhere between 8 and 9, I believe. So up here. But then we have e to the e squared squared, which would be like 16. So this is heading this direction when t is greater than 0. What happens when t is less than 0? Okay, when t is less than 0, let's say when t is -2, we've got e to the -2 power, which is 1 over e squared, so I think right around 1/9 or something. And the y-coordinate is smaller still, at -2, that's e to the -1/4 power, and I'm not about to do the 4th root of e. But this is heading in this direction, like this. When t is equal to -infinity, This is an interesting one to think about. When t is negative infinity, the x-coordinate is e to the negative infinity, which is 1 over e to the infinity, which is approaching 0. So this starts off at 0 and then heads toward just the right branch of this parabola. There is our parabola. This section right here is when t is less than 0. We're heading in this direction. When t is greater than 0, we continue in that same direction, basically. Finally, brings us to number 9. Number 9, we have 1 over t and 1 over t squared. So when t is equal to 0, undefined and undefined. So that doesn't really work. What happens when t equals 1? We get 1, 1. What happens when t equals 2? We get 1/2 and 1/4. And then that looks like we're going to be heading toward 0, 0. And we'll never get there. Okay. If t is greater than 1, then we're going to be up over on that side. Okay, so we can imagine when t is equal to 10, the x-coordinate is 1/10. I'm sorry, negative 10. When t is negative 10, the x-coordinate is negative 1/10, and the y-coordinate is negative 1 over 100. So when t is negative 1, so that's like really close right there. When t is negative 1, we've got negative 1 and 1. So at the very least, we're heading in this direction. And do we get this top half of it? I'm not quite sure that we do anymore. If t gets close to 0, the x-coordinate goes to positive infinity, and the y-coordinate gets to positive infinity from the, if we're looking at values of t that are approaching 0 from the right side, from the positive side, we're going to be the x-coordinate approaches infinity, and the y-coordinate approaches infinity, and it's a square of the x-coordinate. Likewise, when t approaches 0 from the negative direction, we've got the x-coordinate growing, and then the y-coordinate going to the opposite direction. Wait, which direction are we going here? My mistake. I didn't even see the notes I had earlier. We are going in this direction. Okay. So that was 1 through 9. Very challenging, a lot of thought exercises. Hopefully you were experimenting with your calculator as you were doing them. Okay, so for number 10, the parametric graph can be easily reflected around y equals x. If the graph of x equals f of t and y equals g of t, then basically if we were going to reflect it about the y equals x, we're taking the x coordinates and making them the old y coordinates. So if the old y coordinates were gt, the new x coordinates are going to be gt as well, and the new y coordinates are going to be ft. Okay. Which of the above curves is a reflection about the line y equals x for the graph of x squared? So basically, where do we have the reflection of the parabola? And here's one. Here's another one. And the rest of these present the parabola as they are. So this is, let's go to the first one. T squared and t. Oh, maybe we should just write the problem numbers. That is numbers 3 and 7. Okay. For question 11, we're supposed to take the curve from number 8 and reflect it around the line y is equal to x. So let's remember what that curve looked like on question 8, or exercise 8. Exercise 8, yeah, that it looks like just the right half of a parabola. So the right half of the parabola, I'll do this in pencil so that we, if we desired, we could erase it later, and I think I'm not doing a great parabola job here. Yeah, it's good enough. Let's reflect that around the line y equals x. So when you reflect it around the line y equals x, the x coordinate and the y coordinates switch. So 0, 0 stays the same, and 1, 1 stays the same. Anything along that line y equals x would stay the same. Over here, we have inflected upward. So when we reflect it, we're going to have an inflected downward graph. Here, the y-coordinates are going to positive infinity, so now the x-coordinate should be going to positive infinity. So here's what that reflection looks like, and notice it does look like that square root graph, which makes sense since when you reflect the square graph parabola around the line y equals x, you do get a half, or the sideways parabola, which is the square root graph. All right, number 12. The graphs of y squared equals x or y equals root x indicating direction for increasing values of t. Provide a parametric description of each. So these, first of all, if you haven't done it, pause it. Second of all, for these, there is more than one answer. So as I take a look at letter A, I notice that as the y-coordinate, as t increases, the y-coordinate gets smaller and smaller. So one way to make the y-coordinates decrease as t increases would just be to simply make the y-coordinate equal to negative t. And of course, if the y-coordinate is negative t and y squared is equal to x, that means that the x-coordinate is equal to negative t squared, or just the x-coordinate equals t squared. So that's one parameterization. There are more, but this is one we're going to go with over here. So now let's take a look at letter B. So for here on 12B, what I noticed for the y-coordinate, and don't assume that I'm always just looking at the y-coordinate, but it strikes me that the y-coordinate goes out to positive infinity and then comes backwards as we go to as t approaches positive infinity. So the y-coordinate gets big and then the y-coordinate gets small. So what does that say for us? Well, I always want the y-coordinate to be positive, and well, the one that I think is going to work is if y is equal to 1 over t squared. So you notice when t is equal to a very large negative number, we get 1 over 0, or I'm sorry, we get basically 0. And then as t approaches 0, we get 1 over a very small number, which is positive infinity. And then at 0, of course, we're undefined. But then as t gets more and more positive, let's start off t at 1/10. When t is 1/10, you have 1 over 100. And then when t is, say, 1, you get 1. And then when t is 2, you get 1/4. When t is 3, you get 1/9. So we're getting closer and closer to 0 again. So this will have the idea that the function will move outwards and then back inwards as indicated by these directions. So if that's my y, well, the y coordinate is equal to the square root of the x coordinate, or the x coordinate is equal to the square of the y coordinate. So the x coordinate should be equal to 1 over t to the 4th. Okay, so that should do it for us. Graph that, check and make sure that happens. It should go out and then back in. Okay? And folks, that is all of this one. That's a long video as well, a 30-minute long. I said this last time, but hopefully these aren't all going to take that long. But if they do, you know, this is your review for the AP test, and these are things that you really should be thinking about. All right, I'll see you guys next time.